in L&T Defense. Please, sir.
Good morning. We have Dr. K. Sivan, Secretary, Department Space and Chairman ISRO, joining us virtually. Dr. Pawan Goenka, Chairman InSpace. Dr. Uma Maheshwar, Scientific Secretary. Dr. Sudhir Kumar, Director CBPO. Director Devji, my dear friends and people, space enthusiasts from India and elsewhere. Good morning and a warm welcome to every one of you. Space has truly become the fourth economic frontier. Across the world, many nations have looked at space as solutions for their growth strategy, especially long-term growth strategy. LEO and MEO have become the go-to destination and the most happening space in the space now and in the coming future. And over the last couple of years, under the leadership of Prime Minister Mr. Narendra Modi and his leadership team, India has come out with reforms to make a big mark in the space sector, especially bringing about collaboration with the private sector and how ISRO and the private sector can grow the domain, the space domain. So today, anything above the conventional airspace, that is 19-20 kilometers, comes under deep space, and deep space belongs to everyone. And it's only the treaties which have been around for more than many decades, the space treaties which were formed in early 60s and 70s, they still govern the space law. And I think it is time that nations across the world, especially the spacefaring nations, need to collaborate together in bringing about reforms and amendments to the global space treaties and the space laws. And global collaboration in the sector of space is a must, because we feel that as true global citizens, we collectively have responsibilities for people on Earth and people who are wishing to go for beyond. So I once again welcome all of you on behalf of FICCI for this inaugural session of the Space Week at Dubai Expo 2021. Welcome. Thank you very much.
Thank you so much, sir. Now, moving on, I would like to request our guest of honor, Dr. K. Sivan, Chairman, Indian Space Research Organization, ISRO, and Secretary, Department of Space, Government of India, address the audience through his video message. Dr. Sivan worked in the field of aeronautical engineering, specifically in the area of launch vehicle technology, for the past 37 years to make India a self reliant in assured access to space. He is the chief architect of 60 trajectory simulation software, Sitara, and day of launch wind Beijing strategy for ISRO's launch vehicles, which are used in all ISRO's launch vehicle missions. The Gaganyaan program was approved under his leadership. I would now request my colleague to kindly play his video message.
Namaste and greetings from Indian Space Research Organization. Dear Dr. Pavan Goyanga, Sri Uma Maheshwaran, Dr. Sam Dayal Dev, Dr. Unnikishan Nair, Mr. Anthony Murphet, Mr. Vitale Safonov, and other fellow panelists and participants. A very good morning to you all. I am extremely glad to be here and address you all in the World Expo 2021 when India is showcasing the best of her strengths and opportunities to the world. I think it is most appropriate that you identified the space as one of the important areas to be showcased here in Dubai, where one of the largest business event is taking place. As you are aware, today Indian space sector is one of the potential opportunities the vibrant economy of India can offer to global industry. Thank you for the efforts put in by the Ministry of Commerce, FICCI, and my ISRO colleagues for setting up this beautiful space pavilion. The topic selected for this session, the future international participation in space, is highly relevant in today's context, and I would like to share ISRO's thoughts on a few of them. Over the last 6 decades, Indian space program has developed technologies and applications to serve the society. As a gradual progression, India has embarked on planetary exploration and human spaceflight program. Along this journey, ISRO has nurtured the industrial base of the country to meet the requirements of our program. With this rich heritage in space technology, the need was felt to start developing a local space-related economy and also considering the growing demands and the opportunities in space-based applications and technology. To achieve this, the role of Indian industry has to change from the suppliers to co-travelers. So, so the government of India has recognized the need for democratization of space and leapfrog investments and has announced reforms in the space sector for enabling private industries to take up the space activities. Post reforms announced by the government of India, the Indian industry is positively reciprocating to establish self-reliance in the space domain. Presently, ISRO is collaborating with many private space industries and academia, not only in building launch vehicles and satellites, but also in space applications. Especially, startups are very aggressively progressing towards qualifying various critical systems with innovative ideas. So, there are turning points towards setting up a fertile ecosystem for space industries and institutions to create new job opportunities, encourage innovations, and at the same time to contribute to the global space economy. ISRO is fully committed for enabling the industry to take a lead role in the commercialization of the space activities with the technical and infrastructure support available with us. With these reforms in place, ISRO will be putting more focus on the advanced R&D activities, capacity building, space science, planetary exploration, and human spaceflight program. Coming to the international partnership and collaborations, India always recognizes the importance of space cooperation with other countries and shakes hand for mutual development. Space is one of the area India focuses on in establishing international cooperation. So, ISRO has always given trust for this and has a strong bilateral and multilateral cooperation in space with many countries and forums. India and ISRO has been collaborating and contributing to international community to facilitate the use of the satellite services in disaster management, earth observation, and climate studies, etc. UAE is the country, India in general, and ISRO in particular, maintains close relationship in using space science and technology for socio-economic and development. India and UAE have already established the space cooperation dialogues for climate change, Mars science, sounding rockets, stratosphere balloon experiments, satellite navigation, etc. I take this opportunity to compliment the efforts put in by both sides for space cooperation, and I hope the space cooperation will get strengthened in future with more scientific and commercial partnership. If you look at the opportunities in the future, experts have pointed out that the global space economy actually emerged stronger from the pandemic, highlighting the strength and resilience of the space ecosystem. It is well positioned for growing investment, market development, and employment opportunities across multiple sectors. In India, post reforms, huge opportunities are open to industry. The capital intensive ISRO facilities are being offered to Indian industry to generate affordable solutions to the local and global needs. ENSIL, a public sector enterprise under the administrative control of Department of Space, is engaging the private players in manufacturing and launching satellites on demand-driven basis. This is expected to grow in the days to come so that Indian industry will play a big role in the global market. Startups and other MSMEs are also planning to launch their own satellites for independent access to the data and to meet the demands in the remote sensing area. Several companies are already in the process of developing hardware for different applications using NAVIC technology, either for the timing and messaging or for the navigation applications. ISRO joined hands with the NITI Aayog and DPIIT for encouraging the space startups. Many critical technologies developed by ISRO have been offered to industry for space and spin-off applications. With a growing space economy and with the space domain really taking a reshape in India, ISRO encourages and urges the space industry inside and outside India to make use each other's scientific and technological potential, reinforcing intra-block cooperation and actively engage in the joint application of space technologies and other space-related initiatives. We are in the process of revising our existing policies and bringing in new policies for enabling the space industry ecosystem to grow in India. This is also expected to increase the FDIs in the space commerce. I am sure with these efforts, soon India would become a space hub in the region and cater to the peaceful uses of the space to the nation and globe. Coming to the space environment, while making notable progress in space, we also need to focus on making outer space safe and sustainable for further use. This warrants space actors, both government and non-government, to be more responsible. ISRO is giving focus for enhancing the capability of space situation awareness to streamline and address the growing problem of space debris and secure our space assets. ISRO will be open and supportive for all international initiatives to bring in solutions and concrete action plan for enabling mankind to continue to use outer space safely for bringing benefits to humanities. In conclusion, I extend my best wishes to the organizers for their untiring efforts showcasing the pride of ISRO and India on the international platform. I wish them a jubilant success, and this expo shall bring synergy amongst the social and business communities to reach new heights. Thank you all.
Thank you so much, Dr. Sivan, for your thoughts and kind words. Now, I would like to invite Dr. Pavan Goenka, Chairman, Indian National Space Promotion and Authorization Center in Space. He is serving as a chairman of the Board of Governors of IIT Madras and IIT Mumbai. He is the chairperson of the steering committee for advancing local value added and exports, an initiative under the Ministry of Commerce and Industry. He is credited with building a strong R&D and a wide product portfolio for Mahindra, and is also widely recognized as a statesman of the Indian auto industry. Dr. Goenka served on the boards of several Mahindra Group companies, both domestic and international. I would like to thank you for joining us. And now I request him to please deliver his keynote address. Sir.
Thank you very much. Good morning, Dr. Sivan, Mr. Uma Maheswaran, Mr. Laxmesh, and other fellow space co-travelers. It's a pleasure to be here with you today, though virtually. I am very new to the space sector. My association is just about 5 weeks old, and therefore I was very keen to be with you physically and get to meet the space players around the world. But unfortunately, I had to change my plans last minute, and therefore I am interacting with you through this virtual medium. Over the last 4 or 5 weeks, I have interacted with several key players in the Indian space sector, and therefore what I say maybe repeat to many of those. And also I noticed that what Dr. Sivan had just talked about pretty much overlaps with what I'm going to be saying, and therefore my apologies for repeating the same message to all the audience. It is very clear that there is an increasing interest globally in the space sector. It is said that by the turn of this decade, end of this decade, the space sector may grow to about $1 trillion globally. And therefore, there is sort of a space race, and all spacefaring nations are pursuing space very aggressively. And what has changed over the last few years is, so to say, the explosion of private sector in the space sector, led by a company like SpaceX that have made a huge mark in this sector. In India, however, the space sector has more or less been the domain of the Indian government through the Department of Space and through ISRO, as Dr. Sivan had just talked about. There are many suppliers to ISRO, companies, well-regarded companies, but very little in terms of creation of space systems in private enterprise in India, such as design development of launch vehicles, of satellites, of payloads, of ground stations, of downstream applications. up until recently was all domain of Indian government, as I said, through ISRO. In the last 2 years, government has come out with a significant policy change to create a enabling environment for the private sector to come into space, both from within India and from outside India. And therefore, InSpace has been created. InSpace stands for Indian Space Promotion and Authorization Center. And I've been invited to chair the InSpace agency. I will talk a little bit later about the role of InSpace, but also one other major change that has happened in India is creation of NSIL, New Space India Limited. It's a government-owned company, but a company that is supposed to be a front end for ISRO and also work with private enterprises to enable their coming into the space sector. And these two are very significant developments, creation of InSpace and creation of NSIL, which will perhaps change the uh, ecosystem of space sector in India. Now, just to summarize a few things for people who are not very keenly observant of what's happening in space in India, and many of you I know are, and therefore maybe repeat for you. But what India has achieved in the last 12, 13 years in terms of scientific missions are the two Chandrayans, that is the moon mission, the Mangalyaan orbital mission, that is the Mars mission, the Astrosat, and it has own set of satellites for communication, for navigation, for Earth observation. Significant work has been done through what is known as Space Applications Center in agriculture, in marine applications, in urban planning, in rural health, teleeducation, water management, renewable energy, disaster management, and so on and so on. India really has a very high engagement internationally in space. Again, as Dr. Sivan had talked about, there is an engagement with about 60 countries. There are 200 plus MOUs in place. India has launched 300 satellites, out of which 250 are launched for countries other than India. India has 50 of its own satellites in all of the three categories: communication, navigation, and Earth observation. The Department of Space has a huge infrastructure for space. There are half a dozen development centers dedicated to launch vehicles, to satellites, to payloads, to applications. There are multiple R&D labs. And I would like to say that India space program attracts some of the best engineers and scientists coming out of the top universities in India. ISRO has some 10,000 scientists and engineers working in its different centers and labs, highly engaged, highly passionate. And the reason I'm telling you this is the Indian ecosystem for space may be much larger, much more evolved than what many people outside India will be familiar with. There are ecosystem of suppliers, as I said earlier, industrial organizations. But what is new in space in India? And that is why the government pushes there, is the evolution of young startups. The evolution will, in my opinion, lead to a revolution in the space sector in India. Many of them are present here today physically at the Expo. For example, Agnikul, Skyroot, Bellatrix, Digantra, Galaxy, Droid Space, all of these companies are present, and those of you who are from outside India may want to interact with them and understand from them what they are trying to achieve. And I must tell you that you will be impressed with the vision, with the aspiration that these young startups have. Now, what India is doing currently is working on space law, which is pending for a while, and we hope to launch that fairly soon. Working on space policies, new space policies, again, as Dr. Sivan talked about, for communication, for navigation, for remote sensing, and all of these. And again, to give an access to Indian space opportunity to private enterprise, both inside India and also outside India. And it's a fairly major shift, fairly major change from a government-focused space sector to a private enterprise-focused space sector that government of India is trying to bring in. And this is where InSpace, the agency that I'll be chairing, will be playing a major role. In this new plan, ISRO will share technology, infrastructure, knowledge it has. It will, in a way, handhold the young private enterprise in India. ISRO will continue to develop technology and conduct space missions, as Dr. Sivan said, but depend more and more on private enterprise for commercial missions and for applications. But what's coming in future are the Gaganyaan, the Chandrayaan, the Aditya L1, the Venus mission, and all of these. NSIL is a marketing arm, and for the first time in India, NSIL will be working with a private enterprise to give complete responsibility for a launch vehicle like PSLV, which will be completely built by private sector. It has not been done in India so far. It's always been under the ISRO's guideline. We'll be looking to private service. We're looking to provide private service to other nations and firms for launching with as much backward integration as desired. That is, using only a launch pad, a launch vehicle, or having our companies develop the satellites, payloads, even ground stations. All of these things will be open to, and look at it in a very developed manner to become a major space service provider nation in the world. We like to make our suppliers that are here today, such as L&T, LMW, Alpha Design, they are present, to reach outside India. They have a proven capability of having worked on 20 plus missions in India, having had very high quality and at a legendary low cost that India is well known for around the world. We will cooperate with agencies outside India to develop new technologies and joint missions. We have done that in the past. We'll do it more aggressively going forward. In a way, nothing is off limits, including academic R&D. And again, academic R&D is something that is not very well known outside India in what happens in the space sector. But you'll be surprised to see the kind of work that's happening in IITs, then IISCs in the space sector. I do not know if you'll get much of an exposure to that today, but if you're interested, I'm sure that you can find out a lot more, and the organizers will help you to find that out. Now, let me just take a few minutes to talk about what is India's aspiration going forward. India today launches perhaps about 4 to 5 missions in a year using the launch vehicles, the PSLV and the GSLV, which can carry payload from 2 tons to 8 tons. We would want to take it to over a dozen launches in a year. And we believe that we have the launch vehicles, the cost, the quality to make that happen, not just for satellites and payloads from within India, but also for those countries where they do not have a full space program, and even the countries where they have a space program but would like to use our facilities in India. We have to increase our launch pad capacity to be able to do these kind of missions. ISRO is developing a small satellite launch vehicle, which should be ready in less than 12 months for commercial launches. And private enterprise, and 2 of them are present here today, are also working on small satellite launch vehicles, and you may wish to talk to them. These will be very cost-effective, very quick, agile ways of launching a small payload of 300, 400 kilo into the space. India is working on a reusable launch vehicle, the RLV, which hopefully will be ready in 5 to 6 years from now. A lot of work happening on satellite technology, on payload by private enterprise, and being new to the space sector, I'm absolutely blown away with the kind of work that the private enterprises, young private enterprises, are doing in India. And there are a lot more happening in advanced applications in the Space Application Center, and also the work that the private enterprise is working on. I would like to end by saying that the trust that the government of India, coming all the way from the top, from our Prime Minister, is driving the space agenda, and in a way redefining the Indian space sector from being sort of a government-led sector to a private enterprise-led sector, with complete handholding by ISRO. Last week, in a major speech on space, he defined 4 pillars, which will be the foundation of space activities in India. These include enabling environment for innovation for private enterprise, skill development in the colleges for engineers and scientists to get into the space sector, for the government of India to act more as an aggregator of space technology rather than the driver, and also to use space to touch lives of humanities, not just in India, but around the world. So you can see that it, in a sense, a new India when it comes to space that is emerging. And we are hoping that this transition will put India at the forefront of space technology, We are already amongst the sort of 6, 7 nations who have the complete capability for space end to end, and would like to continue to aggressively grow in that direction. And I invite you all to connect with us, talk to the organizers who are there from FICCI. I'd like to thank FICCI for organizing this conference, which I think many of you will find very informative and useful. Or you can talk to any of the companies present. I wish I was there to shake hands with you and talk to you, but maybe some other time I'll get an opportunity to meet all of you. So thank you very much for coming here today, listening to these presentations by Dr. Sivan and by me. And now I look forward to the panel discussion that I'm sure will be very exciting and give those who are not very closely associated with the Indian space sector a complete view on what is happening in India in terms of space. Thank you again.
Thank you. Thank you so much, Dr. Goenka. Now, moving ahead, it's time for the panel discussion. I'm happy to introduce our esteemed panelists who joined us today, physically as well as virtually. To begin with, I would like to invite on stage Shri Uma Maheshwaranji, Scientific Secretary, ISRO. He has made significant contribution to the system integration, checkout, and avionics of ISRO's launch vehicles, PSLV, GSLV, MK, III. He has been the chief designer integration of major sub-assemblies, including equipment, way of launch vehicle. Many of the mission critical circuits residing in the vehicle, including the entire pyro chain of all the 3 launch vehicles, has been designed by him. He is a National Vice President for Indian Society of Systems, Science and Engineering, and the President of ISSE Bangalore chapter. Sir, I would like to join us on a stage, sir, please. Our next guest is Dr. Sam Dayal Dev, Director, ISRO Inertial Systems Unit. Dr. Sam is responsible for the design and development of inertial systems for launch vehicles and spacecraft programs of ISRO. Sir, I would like you to join us on the stage. Our next guest is Dr. Unikrishnan Nair, Director, Human Spaceflight Center, ISRO. He joined us virtually. He was designated as Project Director of Human Spaceflight Program for qualifying critical technologies such as re-entry experiments and other pre-project activities for Gaganyaan projects. After this, he was designated as Director of the newly formed Human Space Flight Center, a new vertical sustained human space missions of ISRO in the year 2019. I would like to welcome you, sir. Next, we have Mr. Anthony Murfitt, Deputy Head of Australian Space Agency. Anthony is responsible for the performance of the organization and has oversight of strategy, policy, and operations of the agency. Anthony is the transitioning for the role of Minister Counselor, Industry, Science, and Education at the Australian Embassy in Washington, D.C. In his role, Anthony's focus is to develop and implement strategies to strengthen Australia's engagement with the industry and innovation, science, research, and education systems in the US and Canada. I would like to welcome Mr. Anthony. Next panelist is Mr. Vitaly Safonov. He is Deputy Director General, JSC, Glascommerce, Russia. Mr. Vitali appointed Deputy Director of General of Glascomos, a 100% daughter company of Roscomos. He designated as the international business operator of Roscomos in January 2017. He held the positions of Deputy Head of the Office at the State of Space Corporation Roscomos. He also served in various positions of the Ministry of Foreign Affairs of the Russian Federation, both in Russia and abroad. He worked as an assistant to the President for the International Relations at the Fund for the Promotion of the 21st Century Legal Technologies. I would like to welcome Mr. Vitali. Next panelist is Dr. Thomas Jorbachan, Associate Administrator of Science Mission Directorate, NASA, USA. He brings a wealth of scientific research, engineering experience, and hands-on knowledge to NASA's world-class team of scientists and engineers. He was also a professor of space science and aerospace engineering at the University of Michigan. He was the founding director of Centers for Entrepreneurship at the College of Engineering and developed and ran several campus-wide innovation initiatives. Thank you so much, sir, for joining us. Now, I would like to invite and I would like to introduce Mr. Sudhir Kumar N, Director, Capacity Building Program Office, Indian Space Research Organization, ISRO. He is going to moderate this session. He assumed key roles in developing enterprise software solution for ISRO for handling procurement, stores, finance, accounts, human resource, core team members for realizing Asia's largest solid rocket propellant plant at Sriharikota. He also part of assembly and integration facilities for GSLV MK III project, radars, and critical equipment for ground systems. He is also in charge of second vehicle assembly building project, the largest rocket integration facility of ISRO, and also handle vendor management from last 13 years. I would like to again welcome all the panelists and moderator, and I request Sudhi sir to kindly start the panel discussion.
Thank you, Mr. Amber. I hope I really, it's a great privilege for me in this great World Expo. It's an amazing platform where space is one of the vertical, where one of the important area has been identified by the government of India. We have very eminent speakers. I should say I am a very small man in front of them. You could listen to Dr. Shivan, Dr. Goenka. All top layer leaders of ISRO are here to speak out or to express the opportunities as well as where and how the space is now being led in the post-reforms area. The space exploration involves high-end technologies, risks, and huge expenditure. The missions conceived by a nation gives a platform for several other nations for carrying out experiments with international collaboration. This is very usual practice in the space domain, unlike other domains. Nations can share the available technologies for joint research and development for peaceful applications. The objectives of the mission can be debated and finalized based on the mutual cooperation and participation that leads to multiple areas of research in one with the missions at the same cost, because that is the most important aspect of the space. This enables to create affordable platforms for carrying out research based on the interests of the individual nations and across the functional domain knowledge for sharing and for collaboration. With this initial probably words, I formally welcome Mr. Uma Maheswaran, Scientific Secretary of ISRO, Dr. Sam Dayal Dev, Dr. Unikeshan Nair, and Mr. Unikeshan Nair could reach Dubai, but unfortunately because of the COVID protocols, he is unable to physically appear over here. He is participating virtually. Mr. Anthony Murphy, Mr. Vitaly Safanov, and Dr. Thomas Jupuchen, who are rather getting connected virtually. To start with, I'll just go to the initial first speaker, Mr. Uma Maheshwaran. Sir, welcome you again. I have a couple of things. Probably, I think you would be the right man to speak on these occasions. As Dr. Goenka also mentioned, Dr. Sivan also mentioned, post reforms, the space sector is really getting open to the NGPs. The government has announced how industry is enabled to gain this global market share, because everybody is now talking about billion market, 347 crore billions right now in 2020. How actually you would see, what is your perspective in this opening up of global space to the global market?
Yeah, thank you, Sri Sudhir. This particular aspect, I think, is well covered by Dr. Shivan and Dr. Goenga. Both of them have really touched upon this subject. So, the vision of Honorable Prime Minister has been transformed into actions now. Basically, the enabling of the Indian private sector to carry out their space-related activities in India, so that in order to enable that, we need to open up the space sector for them. Not only open up, we have to handhold them, we have to promote them. At the same time, these activities, as you rightly told, are there is some risk involved, so we need to regulate, we need to authorize. So all these put together, we need a mechanism. So to have that mechanism only, this in space has been formed, and now recently Dr. Pavan Goenka has been put as chairman of that. So the mechanism has started rolling now. And as Dr. Goenka also told and Dr. Shivan told, we have our public sector unit ENSIL, which is supposed to take care of the commercial aspects of whatever ISRO has been doing earlier with respect to be it a launch vehicle or be it a satellite or be it services. So this is the scenario. All these things have been basically brought out with a vision. You know, as you rightly told, the global space, if you talk about the money flow, it is around, let's say, 360 billion US dollars. And if you really talk about 40% of it is being controlled by NASA. And even if you take, for example, UK, it is only 9%. And in that context, India, if you talk about in that world context, we are about only 2%. So the first and foremost step should be to make it at least something like 9% to 10% in the future, maybe 2030, 2028, 2030 time frame, which Dr. Pavan Goenka himself has been mentioning about that. And maybe the kind of the investment and the activities that the private sector will be able to do from now onwards, I feel definitely by 2024, 2025 time frame, we should be able to be of the 360 billion what you are talking about, at least we should touch about 40 to 50 billion from India itself. There's a kind of target one should really put ourselves on to be significant in the global market. At the same time, developing opportunities in India, developing or creating opportunities for jobs in India, and totally boost up the Indian economy in the way the Honorable Prime Minister dreams, I would say. So definitely, this activity or this action was absolutely adequate, and I feel that it is the right time we have done it, and I am sure that with the kind of activities that we are in future we are going to carry out in tandem with InSpace, with ENSIL, and ISRO, of course, with the Department of Space on the as the premier control, I would say. Definitely, the more and more private sectors, be it large-scale industries, be it MSMEs, be it startups. Really, we are thrilled with the response that I am getting from the startups. Very, very novel, new ideas are coming. You know, basically, when you talk about the money flow, also, in general, the ground stations and the so-called upstream would control approximately around 45 to 46% or maybe around that. And the other applications oriented will be around another 40, 44, 40, 42 kind of scenario. And really 2% only goes to launch vehicle and 5% goes to spacecraft. This is the scenario, this is a reality. So the startups themselves will find it difficult if they invest more and do their activities in applications oriented and upstream oriented. Definitely there is a chance for more money flow to occur. But in reality, I am also seeing that many startups are venturing out. They are I would say they are brave enough to venture into launch vehicles and spacecrafts also with some very novel ideas. So that is very promising, definitely. That's what I feel overall. Thank you.
Thank you, sir. I hope you'll agree with me when you see the Bryce report. It almost government spending would be around 40% that they say in the graph. There is a very prominent and very popular graph. And in that one, space satellite and satellite space manufacturing, space launch vehicle manufacturing is only contributing to 12 plus 7, around 20%. As you said, you are perfectly correct. But that 20% business is generating a business for applications almost 60% of the space market. Well said, sir. I now move on to Sam, sir. Dr. Sham Dayal Dev is heading Inertial Space Unit, the nervous part of the launch vehicle, I should say. And a lot of programs are being undertaken in the robotics, in the artificial intelligence. Sir, may I ask you, the future space is more with unmanned and robotic machines. What kind of capabilities and collaborations are required for such missions? Because many of the industries, they approached us, they are very well prepared for handling such kind of robotic applications. Recently also, one company, you have nurtured them. Probably can you throw some light on what are all the various missions that startups and MSMEs can venture into so that they can prepare themselves for handling the future space robotic missions?
Yeah, thank you. Of course, this is a very interesting question what you have talked about. See, primarily till recently, this cooperation from the Earth observation satellites as well as the applications derived, enormous application what we are talking about, the 60% of. But another part which is really emerging is the debris management as well as the aggressive new technology with respect to communication. That means proliferation or constellation of satellites, etc. So therefore, one very, very critical activity that is going to be in the prominence is on-orbit operations. So on-orbit operations means one is maintaining a spacecraft or a constellation in its place. Another part is the threat, what is coming from the spend stages of the rockets, etc. So how do we handle? So this is a very huge market which is emerging, which nobody can run away from because it is going to face the reality. Even a communication industry has to sustain. They have to have on-orbit operations to maintain collision-free operations in the space. So therefore, that area primarily calls for a lot of automation or robotic missions. So that robotic missions, what we talk about, see, we are not discussing about a predefined process of robotic missions, what has been established. Here we are talking about robotics as well as artificial intelligence and machine learning. So if you see robotics, in terrestrial robotics, there are n number of industries are there. So they have sustained or they have demonstrated the capability. Similarly, the whole world, I think, is now behind AA and ML, and very successfully things are being done. So now, they have a level field, only now the environment is different. That is the space environment. So there, how do we apply this space robotics as well as artificial intelligence and MI? So therefore, there is a very huge scope for startups because now innovation only is the solution to make it cost effective. I think that now the government agencies, industries, academia, and the investors, I think this is a good combination where it can catch hold. And earlier cooperations are from the government agencies' strength to sharing with the industry. Whereas currently, we will be, the government agencies will need to interact with almost equal partners who are already excelled in robotics or AI and ML, but we have to enable. So actually, ISRO is going to play, as Dr. Goenka mentioned, no, as an enabler. So this is true with almost all space agencies. So with it, we enable the innovative industries, the type of robotic activity and that intelligence. So one part I wanted to put is, see, as I said, there is a tremendous growth in robotics and AI, but the type of computing power that is available in ground is huge. Whereas in space, you don't have the luxury of all those. That means very innovative, efficient algorithms have to come from students, academia, or the real startups who have, without, they are, I think they have got an opportunity to work without predetermined notions. Because we, as space technologists, we have learned things in the hard way. So we will have certain way of doing things which may end up costly. But young, as was mentioned, brave startups are coming up. So definitely they can come out with a very cost effective and very efficient to manage all these things. So I see a great potential for the cooperation in primarily between the government agencies, the industry, and industry, I mean that is primarily with the startups as well as academia, as well as the, naturally the investors also will be queuing behind. So I think a great opportunity in the robotics and artificial intelligence and machine learning area in space.
Thank you, sir. Sir, one supplementary question. Do we have any robotic machines in near future? Because many people asked me, I just wanted to give the message through you. In the nearest, either of Gaganyaan mission or anywhere missions, do we have any such programs?
Yeah, see that space robotics primarily microgravity based or planetary based. That is, planetary means, I say, on a lunar surface or on Mars surface, robots entering into it. Another part is with respect to the microgravity. So microgravity means free flying robots which can really do on orbit operations. Another part is, see, enabling as a crew or astronaut assist, etc. So that concept, I think we have also taken up in the first unmanned mission of Gaganyaan. What we propose a humanoid, a Vyomitra, a women, astronaut, humanoid, not in space. So that we have been configuring such that it will have the intelligence and the smartness to see and report, as well as do certain performance operations, crew operations in the first mission. So here it will be an experimental crew operations activity that will be done, but subsequently it is possible even for a tourist sort of a thing, accompanying crew can be a robot, a humanoid can be a crew which will take care of, whereas the tourists can really spend their time and enjoying the trip. So that is a type, to start with, we are having a humanoid. Of course, it will be able to do simple physical functions under 0G. And another interesting thing I want to tell is, this is the first time a humanoid or a robot is in its form is flying. Whereas in other space programs, they had been taken and to the space station and assembled, and there they start performing. So the biggest challenge here is they have to survive this launch vibration and go, and also almost human-like, look-wise as well as performance-wise. That is what is being attempted. So such area also, I think there is a huge potential from all our startups as well as industry.
Thank you, sir. I think ISRO is, many ones are there. This is going to be again one more successful mission. And now I move on to Dr. Unikishan Nair, who is attending virtually. Sir, in the human space mission, because many of the nations like NASA and ESA.
So such area also, I think there is a huge potential from all our startups as well as industry. Thank you, sir. I think ISRO is, many ones are there. This is going to be again one more successful mission.
Dr. Unikrishna Iyer, can you just say hi so that we can test your audio? No, sir, you are muted. Can you unmute, please?
Yes.
Yes, sir. Welcome to you, sir. Welcome to you virtually to this session. My rather question to you is, what you feel critical technologies for manned mission of ISRO, and how ISRO is managing some of them with international collaboration?
Thank you and good morning to all fellow panelists. Gaganyaan, or the manned mission of ISRO, is named as Gaganyaan, is a manned mission program is really an inflection point in the Indian space program, because it's a major decision that the government has taken to go for a human spaceflight mission. And the Gaganyaan, as you are all aware, it is the first part of it. That is, 3 crew, they are going for a short-term mission, 5 days to orbit, 400 kilometers, and then coming back. Definitely, there has to be a sustained space program, so human spaceflight program. And that is how the center, a new center, has been formed and functioning. Now, right from the beginning, and I mean, in all ISRO's programs, this collaboration is a major strength, and in Gaganyaan also it was not an exception. The technologies, right from beginning, it has been decided wherever the technology is available, you have to get it. So we have technologies that we are developing in-house, that is in ISRO centers, and also the industries are participating, and more than 1 dozen national laboratories as well as academia, they are all party to this program. And nearly half a dozen international agencies are also involved in developing the program. Right. So the Gaganyaan, the difference is, till now we have been launching satellites using launch vehicles, but now a human element is added to it. So human-centric products, or wherever human interfaces are there, we need to have high reliable and proven systems. So that is the area where we have embarked on having collaboration with other proven international agencies for procuring the certain systems, whereas most of the systems are getting developed internally or within the country. And we know that this Gaganyaan is going to open up technologies in many areas. In fact, I wanted to say one of the startups in India, they have come with a proposal to develop green propulsion for the Gaganyaan program. You know, this for the crew capsule where the crew is residing, we cannot use conventional propulsion because of the risk as well as the safety involved. Whereas one of the startups has come with a proposal that they can develop green propulsion. So this is a program which is exciting the entire realm of industries or academia, right from startups to the major industries. All of them are participating in this program. And we need many technologies if you look beyond Gaganyaan also. The future is going to be, we are looking at technologies like, can we have inflatable habitats, which can be housed inside the launch vehicle and then inflate in space, and then later we can convert. And Dr. Shamdayal was talking about robotics. We definitely know when we work on, when we step out of the Earth's orbit, definitely the robotics as well as artificial intelligence, that technology is going to play a complementary role. So this is one area we need to develop. And then if you want to have any meaningful long-term mission in space, we should learn the technology of docking as well as space habitat construction, or the construction in space. So that is another new technology which we should master, or which we should develop. Right now, the life support system, what we are using in Gaganyaan, we are storing resources like oxygen, food, and other items. Obviously, such systems cannot be thought of when we talk about long duration mission. So then we enter into a new area called regenerative life support systems. And that is one area that is where advanced technologies are required. Similarly, in materials manufacturing, we are looking for new technologies like electron beam welding, can we make a 3-meter class or 4-meter class structure with EB welding in the country? Because obviously the welding will give more, the structure will be having more better strength than a conventional welding. And what is the role additive manufacturing can play in the future mine mission? And again, Gaganyaan is going to open another new area called bioastronautics, where the survival of humans in low gravity as well as the space environment, and what is the effect of such environment on long term as well as short term human body. Because unless we master such technologies, we cannot think of going beyond the Earth orbit or undertake a long duration mission. And there are spin-offs from human spaceflight program also. We know that space tourism is emerging worldwide. Definitely, this is one area we can also work. Space tourism is really, we are going to the Carmel line, 100 kilometers and just coming. It's a question of staying in space for a few minutes. It's giving a sort of a microgravity for a few minutes. Definitely, it can find a lot of market in the Indian context. And to summarize, though we talk about human space flight, it is going to open up. It's going to open up. It's going to excite. It is going to open up many areas of science and engineering. And I am seeing in the Indian context, it will definitely ignite the youngsters' mind in the country, and I am sure all the industries as well as academia will be playing a major role in realizing history. Thank you.
Thank you, sir, for very greater and wider insights and your perspective. Now, shall we move on to Mr. Anthony Murphy? Mr. Murphy, can you say hi so that?
Hello, good to be there with you all.
Most welcome to the session. I have a couple of questions to you. The keeping target of 12 billion by 2030 for the Australian space and establishing a very quiet and healthy supply chain. What kind of participation Australian space plans to involve the supply chain, and what are the challenges to face the global competitions?
Yeah, thank you for that question. Hello, everyone. I'm Anthony Murphy, the Deputy Head of the Australian Space Agency, and it really is a delight to be here with you all today at Expo 2021, virtually, of course, and in the Indian Pavilion. It's a real privilege to be able to join this session. Thank you for those questions. I will touch on our mission, which is very much that industry-focused mission that we've heard many of our speakers talk about already. When we were established 3 years ago, we were given a very clear task to triple the size of Australia's space sector from around 4 billion Australian to 12 billion and create another 20,000 jobs by 2030. And one of the big reasons we have that opportunity is that transformation of space that many of our speakers have spoken about, whether it's the use of new satellite platforms to take images of Earth to understand disasters or monitor the environment. But it's particularly around the businesses, because we've seen a massive transformation here in Australia. What we've seen, just some statistics, we've got our industries now growing at the moment at around 4%, which is above our GDP, and it's forecast to be growing at around 8% over the coming years. And since we've been established, have seen around 2 billion Australian in inward investment into Australia and its space sector. So we've got a great opportunity before us, and it's because the space sector here in Australia, we're seeing that transformation from an area where it was just governments, and now we're seeing this thriving ecosystem. I want to commend India and its new policy and how it's really thriving and looking at how to engage with businesses. And I think, as I'll end this session talking about how there's opportunities for our businesses to collaborate, hearing from InSpace and others about what can be achieved. And I think global collaboration will be an important part. So as we look at Australia and what we do and how we're getting to our particular target, what we started with was actually looking at Australia's strengths in Australia. What we identified is that we had some some known strengths because of our location in the southern hemisphere. So again, we were involved with space communications, and we've been involved with space communications since the 1960s. What we're now looking to do is to leverage that experience, for example, moving into advanced communications and optical communications. But importantly, one of the big reasons that we have opportunities in Australia is we've got many adjacent industries that could play a role in space. So if we have a look at our mining sector or our resources sector, many of the activities that are undertaken in that sector are automated, use robotics, and they work in very, very harsh environments. As an example, some of our mining sites are up to 1,600 kilometers or 1,000 kilometers away from when they're actually controlled. So many of the platforms that we use in our mining sector are automated. So what we've done is have a look around Australia, all the sectors that haven't even thought about space and whether it could be a business opportunity, and then see whether we can transfer that technology across. For those in the audience that haven't or may not have heard, it's because of that capability in robotics and automation, and for the ability for our mining sector to control, for example, the very large trucks or their drills from afar. It's one of the reasons why we've partnered with NASA in our $150 million Moon to Mars program. And last week we announced that we will be building a 20 kilogram rover that will go be on the surface of the moon. And what it will look to do is to move regolith and move it into another facility or mission project that's being run by NASA, with them to investigate extracting oxides. The part that we will bring is not necessarily the 20 kilo rover, which is actually quite small. It's actually the automation technology behind the rover that we will be looking to show, and that technology comes from our space sector. That's a long way to answer your question about how we're looking to build things, because that rover isn't going to be built by the Australian Space Agency. We're going to support it and we will fund it, but we're looking to work with our businesses and researchers, and we will fund 50 million Australian to our businesses and researchers to come together and really develop that rover and the platform, leveraging that adjacent industry. So that's one way that we're looking to build our space sector here. Talking about supply chains, one of the things we have done, and for those in the audience, we are an emerging nation. We know that international partnerships are really, really important in collaboration. But importantly, how do we integrate into supply chains? So again, around 2 years ago, we released an Australian civil space strategy, and we were very clear in the capabilities that Australia could play, whether it is in the automation, robotics, in emerging areas such as space medicine, leveraging our experience in Earth observation data, or taking a greater role in PNT and increasing the resolution. So we've been clear to the market to outline where Australia could potentially play a role. And then to build the capability of businesses, this has been the big thing that we've had to focus on to get into supply chains. Our Moon to Mars program, which I spoke about, a really important part of that program is called our supply chain capability program. And what it focuses on is provides our Australian businesses with funding to show that they can transfer their technology into space, or ensure that they have the standards that are required to meet the higher level of standards to work in a space supply chain. So there's some of the examples that we've been using to, one, build the capability of our businesses, and importantly, what we want to do is showcase what we can do. Coming to your last question around challenges, I've touched on those through some of our programs. I think the first thing Australia had to do, being an emerging nation, is to show how we can contribute into the global space economy and participate with larger space agencies such as ISRO or NASA or JAXA. And the way we've done that is to really look at our capabilities and look at gaps in the market internationally and where Australia could potentially participate. The other challenge that we're now working through is making sure that there's infrastructure available in Australia so that the companies can operate in space or show that it can get space heritage. So we've built and funded mission controls for our businesses to be able to control their space assets here in Australia. We're also, I've talked about our supply chain program to build individual capability. And we're also looking at investing in payload qualification facilities to ensure that businesses here in Australia can test their hardware before it goes to space. So they're just a couple of examples of, one, how we're trying to get to our vision of and our mission of another 20,000 jobs by 2030 and tripling the size of the space sector, focusing on this amazing expertise that we have in other industries to transfer them into space. And of course, some of those challenges. And the last one I would probably leave with, this is very important to Australia, is that we have to connect with the community. We have to be very clear on the value that is provided to our community through investment in space. And this is, I think, one of the great things India has done with its space program. It's very clear how we can use those images from space to help and monitor drought, to help agriculture. And again, every investment we look to make in space, we look to ensure that it actually has a return with our the Australian community, so they have a clear understanding about why we're investing in space. We know there's a range of challenges such as COVID-19, healthcare, and it's important that when government makes this investment, we're very clear about what that return is to the Australian public. So thank you for the opportunity for the discussion today.
Thank you, Mr. Anthony. We'll move on to Mr. Vitaly Safanov. Mr. Safanov, can you say hi?
Morning. Good morning, everybody.
Very
Pleasure
good
to
morning.
be with you today.
Most welcome to you to the space panel discussion. Roscosmos is working on various programs like lunar programs, own space station, etc. What do you think that what are the collaborations and framework for the future programs of Roscosmos?
Thank you for the question.
Space rather. You are just
I have a small presentation for you to share. If someone could switch it on, because I am not allowed in the program to do that.
Chirag, can you share? Can you allow him to share the presentation? Yeah, it's visible. It's visible. You can open you can start the application. The presentation is on. You can proceed.
Great, thank you very much. So I would like today to highlight some international program in space from Russian point of view. A lot of programs are realizing and will be realized. So I will touch on the most interesting one. Please, next slide. So I can but start with our cooperation with India that hosts today's event. We are proud to have a long, more than 45 years and successful history of space cooperation. It includes the launch of first Indian satellite, Aryabhata, in 1975, the launch of the first Indian into space in 1984 to the Salyut 7 space station. The technological cooperation between our countries started in 1991. Glove Cosmos, with Russian industrial partners, developed and delivered a consignment of cryogenic oxygen hydrogen steps for GSLV rocket and supported in their preparation for launch from Shar spaceport. So recently, since 2019, we have been involved in the realization of Gaganyaan project. We assisted in selection, medical examination, and space training of future Indian astronauts. The training has finished earlier this year in Gagarin Space Center. And we also supply different system components for future Indian human spacecraft under the Gaganyaan program. We are confident that our side-by-side work with Indian friends will last for a long time for the benefit of future development of our countries. So next slide, please. So it's about the most significant from my point of view international project, International Space Station. Everybody knows 5 space agencies, 14 countries. So difficult to add something new, but this year was particular for us. The summer we launched a new model Nauka, successfully docked it to the ISS. And this module will allow us to increase the capabilities in scientific and research program and the station, increase storage capacities and oxygen production, and will provide an onboard workshop and the crew quarters for a third crew member of the ISS Russian segment. Now Russia is always open to international cooperation in human space programs. Being at Dubai, also virtually, I can't mention but our cooperation with Mohammed bin Rashid Space Center on launching first UAE astronaut, Kaza Al-Mansouri, aboard Soyuz spacecraft to the International Space Station in 2019. And today we also had an important event. You probably heard about our recent project, The Challenge, the first feature film made in orbit, and the crew with the actors and film director successfully returned to the Earth 2 hours ago after being on orbit 12 days. Now they will continue their work for film production. Next slide, please. Another important project for us is Soyuz at the Guyana Space Center. It's our project with French partners that started in 2002 when we signed the agreement of the creation of Soyuz launch system in Kourou Space Center, French Guyana. Under this cooperation, we developed the initial data to design facilities of the Guyana Space Center and technical system of the Soyuz launch complex. We also designed, produced, delivered, and assembled the ground support equipment for the Soyuz launch complex. The very first launch from the Guyana Space Center was performed in October 2011 by the Soyuz ST launch vehicle. Since that, 24 more launches have been conducted so far, and the complex has great potential, and we believe a lot of programs and international programs will be realized there. With our French partners, we are implementing the launch program for OneWeb satellites. The latest launch was from our new spacecraft, Spaceport Vostochny, on this Thursday. It was 11th successful launch of Soyuz under this project. The launches are performed from 3 different spaceports: Baikonur, Vostochny, and Kourou. We will continue the realization of the program this and next years. So next slide, please. Next project I would like to introduce briefly is our joint project with Kazakhstan for the creating the rocket compound on the basis of Zenit M launch site at the Baikonur Cosmodrome for the launches of the next generation Soyuz 5 medium carrier rockets. Russian side is responsible for the development of launch vehicle, and Kazakhstan will modernize ground facilities. Next slide, please. There are a lot of other international projects Russia is realizing. I should mention our project with the European Space Agency, ExoMars, in the exploration of the Red Planet. Our joint project with German Space Agency, Spectre RG, in the exploration of deeper space. Also, International Scientific Lunar Base that you mentioned previously is a Russian-Chinese joint project that is open for international partnership, and that is very important. The International Lunar Research Station will consist of a space station in lunar orbit a moon base on the surface, and a set of mobile rovers and intelligent so-called hopping robots. The station will provide a range of scientific facilities and equipment to study lunar topography, geomorphology, chemistry, geology, and internal structure of the moon, as well as enabling space and Earth observation from the moon's surface. It will also likely support human exploration in the future. And I will repeat, it's an open project for international partners. Well, to sum up, I've tried to show you the different projects Russia is involved in different areas: human space flights, deep space exploration, scientific programs, launch vehicle developments. Almost all of them deal with the development of the critical technologies for space exploration. And we are open to such cooperation because international partnership, international cooperation is very important for the humanity to go forward in space exploration. The only thing I would like to mention, the important issue for us is that this cooperation should be based on the principles of equality between all partners. So the last slide, please. Let's go to space together. Thank you for attention.
Thank you, Mr. Sarkar. Let's go to space together. It's a wonderful caption. Thanks for your perspective on the Russian space. Now we will move on to the final panelist, Dr. Thomas Jurbichan. I think he's not available in virtual. I think there is a recorded message, as I understood. Can I just ask the organizers to play the message?
Hey, I'm Thomas Zurbuchen, the head of science at NASA. I want to thank you for allowing me to join you today at the Indoor Pavilion at the Expo Dubai. Though this is a virtual experience, I am pleased and honored to be on stage alongside with ISRO and its counterparts and representatives from the Australian Space Agency and Cosmos. Cooperation between NASA and India extends back decades, starting in the 1960s with a telemetry receiving facility in India and training Indian space engineers at various NASA centers. Our cooperation has been strengthening to this day across many NASA disciplines. Today, I'm pleased to be able to highlight a few of our science collaborations with ISRO. One of NASA's most significant partnerships is the NASA-ISRO Synthetic Aperture Radar mission, also called NISAR. This is an Earth science mission to measure Earth's changing ecosystem, dynamic surfaces, and ice masses. NISAR's observations of biomass, natural hazards, sea level rise, and groundwater will drive better scientific understanding of the effects and pace of climate change. NISAR will contribute to our data models, which are so fundamental to our understanding of the Earth system that drive climate change. Those models accelerate our predictive capability and assist us in delivering actionable science that help us plan for, respond to, and mitigate climate change impacts. NISAR is also the trailblazer mission for NASA's next generation space-based observation architecture, the Earth System Observatory, or ESO. We are building the ESO to meet the recommendations of the 2017 Decadal Survey of the National Academies in the United States. ESO will study aerosols, cloud convection, participation, mass change, surface biology and geology, and much more. By doing so, we will significantly improve our understanding on how the Earth systems work together. Observations of snow depth and water content, atmospheric winds, ocean surface winds and currents, and greenhouse and ozone gases are interesting on their own. But the value of the ESO is from taking these measurements together as a single observatory, able to provide us with a fully holistic, three-dimensional view of our Earth. The key to realizing the value of the ESO is open source science that harnesses the exponentially higher data volumes which we expect. ESO missions will present challenges in data storage, processing, and analysis because of the quantity and heterogeneous nature of these data. Because of these challenges, we have a unique and immediate need for improved data sharing and collaboration. We will use open source science, and we define that to be a collaboration culture enabled by technology. This means not just sharing scientific findings, but opening and giving access to the data, information, and knowledge within the whole scientific community. There are many benefits to open source science. For instance, fostering greater collaboration and lowering barriers to entry into scientific exploration will broaden participation and increase the diversity of our community looking at these data. We can improve transparency and reproducibility through open source science, shortening the time it takes for new users to find and use these precious data. Open source science increases public awareness and citation of Earth science, which could lead to an expanded investment. Finally, open source science enables scaling of large data sets for societal benefits and improves data system efficiency. NASA plans to use an open source science policy for the entire Earth System Observatory. This means that all mission data, metadata, software databases, publications, and documentations will be available on a full, free, and open, unrestricted basis. There will be no period of exclusive access. Science workshops and meetings shall also be open to broad participation and documented in public repositories for you and all of others to see. An amazing example of sharing science data is the COVID-19 dashboard we at NASA created in collaboration with ESA and JAXA last year. By collating these data from Earth-observing satellites, instruments aboard the space station, and ground-based networks, this tri-agency dashboard documented planet-wide changes in the economy and the environment in areas such as shipping, construction, agriculture, water quality, and climate variations. Using the COVID dashboard, scientists and decision makers alike could access many different tools, data sets, and methods to investigate these changes in the Earth system and then compare these complementary data sets to reveal a deeper story on how the environment changed due to COVID-related shutdowns. Looking ahead, we're excited about the scientific advances that we can make with open source data and especially open source science on our upcoming missions. Next week, I will be going into greater detail about the Transforming Open Source Science Initiative at the International Astronautical Congress, IAC, in Dubai. In closing, I would give my special appreciation to Dr. Sivan and Dr. Umameshwaran, my friend Uma, who are also speaking here today at this event, as well as our hosts from the Federation of Indian Chambers of Commerce and Industry and the India Pavilion and the Expo organizers. If you're in Dubai at the Expo, make sure to check out the NASA lunar samples and Mars meteorite at US Pavilion. I look forward to seeing fellow space leaders, professionals, and enthusiasts at the IAC next week. Thank you.
Thank you, Dr. Thomas. I think we have come to the end of the panel discussion. Probably I thank, to summarize, Dr. Uma mentioned about the perspectives of ISRO opening to the public, rather private entities globally, the research opportunities as well as industrial collaborations that is possible, which are open to the entire globe. And Dr. Shamdayal Dev mentioned about the opportunities in the robotic experiments and artificial intelligence, how actually we can bring the entire country together to have a collaborations. And Dr. Unikishran Nair mentioned about the Gaganyaan program, where most of the technologies have been conceived and have been, let us say, put into place through the collaboration as well as the participation basis, because we call it as in ISRO, the Gaganyaan program is not ISRO's program, it is a nation program. That's what very widely the senior speakers talk about. And over to Mr. Vitaly Safanov. He has mentioned very widely what Russian space is going to undertake in the couple of years to come, both in lunar missions and Mars missions along with the other nations. And Mr. Murphet has a very ambitious target. He has put it across for the Australian space, where he's going to touch 12 billion economy by 2030. At present, 5 billion space economy within Australia, with the increasing the supply chain. And finally, Dr. Thomas, he has highlighted several programs with ISRO like NISAR and which is a very vital mission, global mission, I should say, on cooperation basis, which will do a lot of work on the biomass, groundwater surfing, climate changes with open source science. I think I thank all the panelists, eminent speakers who talked about the various opportunities on the global basis and participations on the global basis. I again extend a very sincere thanks to all the panelists. Thank you very much. Not least, Mr. Hegde, who's supposed to moderate this session, is back of the thing. He's also overhearing. Probably, I think he would extend his satisfaction for the panel discussion, even though he could not attend it personally.
Yeah, I'm indeed happy. Let me tell a word of appreciation to my FICCI colleagues and all the participants. And thanks, Sudhir, for a good job. Thanks very much. Good day.
Now we will move on to the next session. Maybe a couple of minutes are left in the schedule. Can we take some question answers from the audience, because the time is not there, another 6 minutes left. If any questions are there, we can take. Thank you. In that case, probably, please, you are one of the audience.
So that's why I took his permission to ask the question. So this is, of course, to all the stalwarts from across the countries. And the question is, with so much of aggressive opening up of the space from practically every nation and deploying space for all their strategic intents. So how do you see the global collaboration building up towards making space genuinely a common place for everyone? And this is question to anybody and everybody on the panel.
Thank you. SSR, would you like to?
No, Lakshmesh, really, the whole intention of the opening of the space sector is exactly aimed at that only. Even though we are saying that the thrust will be given for the Indian entrepreneurs to carry out their space program in India, it will definitely not limited to that with the FDA policies, etc. You know, a host of 10 policies are going to be set up soon, which includes FDA policy also. The opportunities for the international agents also to participate in the space activities, of course, with certain defined constraints. I will not say it is a constraint, kind of boundaries or kind of the way SOPs, I will put it that way, to carry out these space activities. So ultimately, the vision will be that anybody from India will be able to globally compete for any activity that is going globally and vice versa. So it doesn't mean that, for example, NSIL, it doesn't mean that, for example, I'm giving a very fundamental example. Now, NSIL to make their launches in their commercial domain, presently they are depending on ISRO only. But ultimately, NSIL need not compete. NSIL can really make ISRO compete. So Ensil can make, it can go to SpaceX and get a launch vehicle for doing a commercial business. Who stops? And vice versa, sometimes SpaceX can come and launch in India. So this is a kind of global vision and global scenario that we are extending. This is already happening as far as the space, the services are concerned. You know very well, services is global now, practically. So that is why that more fund flow is also happening there. Similarly, in launch vehicle scenario, in satellite scenario also, a global trend will definitely happen if you open up, and it should be mutual also. It is not that one-sided kind of scenario also should not be there. The way we are able to compete, others are also should be able to compete, and that should be a healthy kind of scenario situation should come, and then can change the entire perspective of the space activities that is going on. This is what I perceive. Now we are in a position to play.
Thank you, sir. To supplement Lakshmi's question, I have a supplementary question to probably to Dr. Goenka. Sir, I hope you are listening. Dr. Goenka. I think he's not able to. Fine. Okay. Yeah, please.
First of all, thank you, all the gentlemen, to give me opportunity to ask my
Yes, I
question.
am. Dr. Goenka. Yes, I am.
Goenka ji, I would really like to understand how ISRO bodies and
Hello.
other.
Sir, you are audible, sir. There is a question from the audience.
Hello.
Hello, sir.
I'm listening.
Okay.
Thank you.
Yeah, I'm listening.
First of all, thank you. My name is Rajesh Muneshwar, and I'm an expert in designing, manufacturing of launch vehicle and biopropellant rocket propulsion systems. I have two very specific and particular questions, sir. First, Indian space authorities and government agencies, how do they address the issues of granting the space launch vehicle integration, propellant handling licenses to the private sector? This is my first question. In past, we have seen some issues and very critical issues about launch permissions and issuing the launch insurances. Second, my another question is, government of India, ISRO agencies, do they have any vision about in-orbit space servicing of satellites? My particular question in the space maintenance services in orbit will be about in-space refueling. So, in near future, does ISRO has any vision about modern satellite systems which could adapt for in-orbit space fueling? Thank you.
So thank you for your question. I think second question is better answered by one of the scientists from ISRO. So I'll defer that to either Mr. Muni Krishnan or Mr. Vamaiswaran. The first question really is that's the essence of why InSpace is set up. How does InSpace facilitate the collaboration between ISRO and private enterprise? How does it do handholding, make the all the infrastructure capacity, the development infrastructure available to the private sector? And the whole procedure is evolving now. As you know, it just been announced just few weeks ago. The procedure is evolving, and I'll be talking to all the players in the private enterprise to get their inputs on how to best facilitate that to ensure that the objective that we have set out are met to full satisfaction of all the stakeholders involved. Can somebody answer his second question, please?
Coming to the refueling on orbit, this is an endeavor which is basically done to elongate the life of the satellite. So basically, this also is one of the co-activities related to space debris problem, wherein the spacecraft no longer continue to be a debris, but it is an active satellite. Also, there is also another thought process of space debris related thing, wherein make the satellite lie, bring it back to a point where you can deorbit it. Is one of the co-activities related to space debris, where you can deorbit it and it will enter the atmosphere and burn itself. So these are all some of the activities ISRO is very keenly planning to do on this. The answer is yes, and this is part of our decadal plan. It may not happen immediately, but actions are on.
I would like to substantiate what Mr. Uma Maheshwaran said. You see, our PSLV, the fourth stage, we are actually trying to use as an unmanned orbital platform for doing experiments. In that, such experiments are being tried, like whatever I was saying, like free flying, robotics, etc. Also, see, it is not only for refueling, or you need to see that either it is reworked or repaired. It's a very coarse way if I put it. Also is done. Not only the most of the satellites you will find for some other reasons also they do have failed to perform or continue to perform. So all these activities on an experimental basis, yes, ASRO is doing so that they can be applied onto the real application as it is emerging now.
Thank you, sir.
I just would like to.
Unikishan, sir,
I would like.
can you just
I
throw
would
on
like.
SPADX and docking technologies?
No, I would just like to add to this previous question on the fuel depot. It is something which is being discussed worldwide. That is, you have a like a petrol bunk, you have a refueling station in space, which can extend the life of satellite as well as which can be used for fueling satellites that are or satellites or even vehicles that are going to other planets or asteroid. In fact, studies are going on, but not much is done in the Indian context. Probably this is one area we can start working on it. Now, what is the next question, Sudhir?
No, SPADX and docking, because extension of the Gaganyaan program, can you just throw some light? Is it possible?
Yeah, this I just touched upon. SPADX is 2 satellites in orbit, just docking and de-docking, but a technology demonstration experiment that is being taken up by the URSC. You know that in any meaningful habitat or construction in space, we need to take modules and then dock, and finally they should be connected together. So it's I would say it's just a beginning or a technology demonstration of how 2 small satellites can be docked. So when you do small satellite docking, the challenge is more because basically the small satellites have a very low mass and moment of inertia. Any small disturbance, very difficult to bring them closer and then do the docking. But it is a platform where the technology as well as the algorithm and the proximity sensing and all related ground control, everything can be demonstrated, which can be later scaled up.
Thank you, sir. I hope this answers your question. One more question which is answered is you are asking about the licensing for handling the propellants. Even today, the industry is handling the hazardous propellants. You take it as solid propellants. Even today, there are 2 companies that are handling the solid propellants with the available technologies. And whatever the fuels that we use as a rocket fuels, either is a cryogenic propellants or earth storable propellants, they are coming from the industry only. So there the license is available for manufacturing. As the activities and the law goes, that is space transportation activities, when the law and it is enacted, so the rocket filling and other things, how actually the safety thing has to be addressed, and that will be covered as a part of the activity bill. That will come out. That's what Dr. Goenka mentioned. Thank you. I hope he's touched at 12:45. Probably, I think we can close the session. I'll hand over the mic to the organizers. Thanks again for the panelists for excellent panel discussion. Thank you.
Hello. Thank you so much, all panelists joined us, either virtual or physical. It's quite informative. Thank you so much for joining us. Now to move on, I would request Mr. Rohan Ganpati, CEO and CTO, Bellatrix Aerospace, to please deliver the closing address and vote of thanks. Mr. Rohan.
Ladies and gentlemen, very good morning to one and all. I represent the startup community from India, me and my friends. We are celebrating currently the 75th year of independence. And in these 75 years, 50 glorious years of existence of ISRO. And proud to say that the only organization which was started without, the defense side attached to it. So it is for the benefit of common people. And what you saw here in this session today is how global people came together, and that's what space is. It's all about globalization. And the main impact is what we as a country from India with 5,000 years of heritage dreaming about space can really do more about, really going up to space. So on behalf of FICCI, which is the voice of India's industry, now it has also become the voice of India's industry to space. I would like to extend my thanks to Chairman ISRO for gracing the occasion as guest of honor and delivering his insights. What an inspiration he is. And to Dr. Pavan Goenka, he's also an inspiration to see how he has driven Indian industry, and we look forward to work with him. And the great panel moderated by Mr. Sudhir Kumar. What you see here is Mr. Uma Maheshwaran being the scientific secretary, importance of systems engineering, how multiple technologies can come together to deliver one goal, and his views regarding space industry as well. And then Dr. Sam Dayal Dev. You see, there are many countries in the world with capability to launch rockets to orbit. But how many can give you the accuracy and the precision you require to inject your satellite so that you can save onboard propellant? His work actually corresponds to that. And thank you for his insights as well. And Dr. Unni Krishnan Nair from HSFC for talking about India's great vision for enabling human access to space. And our friends from Mr. Vitelli, Mr. Anthony, and Mr. Thomas from 3 different countries and 3 different time zones. Thank you for taking time out and addressing this panel. And the message which we take from all of you is basically space is a global industry, and how we as human civilization can come and work together to ensure common good for mankind. And especially from India, there is lots to offer. And finally, to Sudhir Kumar sir for moderating the session very well. And once again, on behalf of FICCI and the startup community in India, thank you for taking your time out. Have a great day.
Thank you so much, Rohan. Now with this, we have reached to the end of this program. But before ending the program, I would like to invite and inform you that today at 3 p.m., we have one more seminar. The name of the seminar is Opportunities in Aerospace, Defense and Space Sector of Karnataka. Both IT Minister and Industry Minister is joining for this program. So I would like to invite all of you to please come and join us at 3 p.m. in this same venue. Thank you so much for joining us today. I hope you have gained a lot of knowledge, and it's quite informative also for all of you. Thank you so much for taking time out of your busy schedules. I hope you will enjoy the Dubai Expo. Thank you so much for joining us. Thank you so much.